One, Cameron Joyce from Get-SysadminBlog and Article of Networks here, and today we're going to be going through part one of building our travel size secure network. Uh, Today we're going to be going over some pretty basic stuff. We're going to talk about installing the Raspbian OS on the SD card and what you need to do to configure that for a headless install. We're going to create a new user account. We're going to replace the default built-in account with a new Linux user account. We're going to configure UFW, which is a software firewall on the Raspberry Pi. We're going to limit some connections and make sure that the local security is pretty good. And then we're going to overclock the Pi. So we're not going to get into installing any of the additional packages today. Really, we're just getting a Raspberry Pi out of the box, ready to go to do whatever is next. So the first thing that we need to do is we need to prep the SD card. And I have my SD card prepped. I am using the Raspbian Imager for Mac. So basically, this is taking all the guesswork out of imaging your Raspberry Pi. It'll grab the latest OS image from the internet. It'll install it, validate the SD card, and tell you it's ready to go. In this particular case, you can see that we used Raspberry Pi OS Lite. Why are we using Lite? Well, Lite is the minimum package install. So basically it has no desktop environment, no GUI, everything is from the shell. And that's what we want. We are only going to use this as an SSH connected device. We're using this as a server. We're not going to need to hook up a monitor and a keyboard to it and use it as a traditional desktop. So I used OS Lite. You can see that I installed it to my SD card here. And the next thing that I need to do is I need to create the SSH file. The SSH file basically tells the Raspberry Pi on first boot to enable the OpenSSHD server, allow connections from anywhere, and use password authentication. It's basically just kind of that, hey, let's make the system wide open so you can get in, and then once you're in, you can lock it down. On Windows, you can do that through the GUI. In Mac, I prefer to use the command line. So I'm going to open up a terminal here, and I am going to say touch/volumes/boot, because I know that the Raspberry Pi uses a volume named boot, though we're not seeing that here. So let's go ahead, let's pull the SD card out, let's put it back in. And we should see that boot volume come up. There it is. So volume/boot. And we're going to say SSH. There doesn't need to be anything in this file. It needs no file extension, just touch SSH. And we can verify that that's in here by doing ls/volumes/boot. And now we can see that we have an SSH file in there with no file extension, no content. It's literally just looking for that one file to, in the boot config, tell it, go ahead and open up SSH. So we're going to go ahead. I am going to eject that volume, and we're going to put it in the Pi. We'll boot it up, and we'll come back once our Pi is booted up and on the network. Okay, so we pulled the SD card out of the laptop, we put it in the Raspberry Pi, we boot the Raspberry Pi up, and we let it get a DHCP address. You'll notice that I'm seeing in my SonicWall here, I'm using my SonicWall as my DHCP server at home, and you'll notice that this address is assigned to Raspberry Pi, so gives me a pretty good idea that this is the right device. By default, Raspbian uses DHCP for the Ethernet, and it leaves the Wi-Fi disabled. So in this case, I'm going to configure everything in my normal home network, and then once I've got everything configured, I'll give it a static IP, and we'll start to build the dedicated second network. But for right now, this is what we're doing. So I'm going to take that IP address, and I am going to say SSH Pi at that. I'm going to add the fingerprint, and I'm going to put in the default password, which is Raspberry. Okay, great. So now I have a default login, completely clean Pi, totally new installation. And the first thing that we need to do is we need to run the Raspberry config to set a few basic things in the Raspberry Pi. So I'm going to do sudo raspberry config. We're not going to worry about any of these three options. Usually you would want to change the password of the default account, but we're actually going to get rid of the default account, and then we're going to disable password login for SSH. So it doesn't really matter, right? We can skip that step, even though every tutorial is going to tell you change your password. The host name, we're going to change that. We're going to call it TSSN Pi01. There's only going to be one, but again, I'm an infrastructure guy. I just can't get that out. I got to enumerate everything. If we go back to system options, the other thing that we want to do, actually, that's not in there. So everything else here is good. We don't need to worry about display options. We don't need to, actually, I think, nope, we don't need to worry about display options. We don't need to worry about interface options. In performance options, we're not going to worry about overclocking. We're going to do that with the boot config later. This menu actually doesn't work for the Raspberry Pi. GPU memory, we are going to change that down from 64 to 16. Again, since we're not doing anything with the GPU, no reason to give it shared system memory, so we're going to bring that down to 16 megs. Under performance options, don't need any of those other things. Localization options, we are going to update the time zone to be US Central, which is where I live. And in localization, we are also going to set the WLAN country to be US. Again, we're not going to need it, but it complains about it, so I'm just going to set it. Let's see, advanced options, don't need anything in here, so we're going to go ahead and back out of that, and we're going to go ahead and we are going to finish. It's going to ask if we want to reboot. We're going to tell it if we do. Reboot's going to take a couple seconds. And we'll just start a quick ping to watch it reboot. Raspberry Pis reboot pretty quickly. They're pretty lightweight, usually 30 seconds or less. So as soon as we've got ICMP responses, we'll go ahead and we'll log back in. Okay, there's my responses. So we'll go ahead, we'll SSH with that same Raspberry password. Okay, great. So now you notice that the warning about Wi-Fi killed because there's no country set is gone, and we're just getting a warning about SSH. So the next thing that we want to do is we need to update this Raspberry Pi to the latest version of all of its packages. So we're going to use apt to do that. And actually, I want to tell upgrade and dist upgrade to not bug me. Okay, so what this is doing, it's going to go out and it's going to get the latest version of all the package lists from its known mirrors. It is going to compare the latest version versus the local package list. Obviously, if the remote version is newer, it's going to download that and install it. It's also going to do that for all the dependencies. So it's going to do all the base layer OS updates, the security updates, SSHD, everything. It's going to pull all the packages. And then with auto remove and auto clean, what we're doing is we are cleaning up boot images that are no longer needed. We're removing packages and dependencies that are no longer needed. And we're just keeping the package list as up to date and as clean as we possibly can. So this is going to take a few minutes to complete. And once this is done, we'll come back and we'll look at creating that new user. Okay, so now we've gotten the Raspberry Pi completely up to date, latest version of all its packages. We removed some depreciated packages. I can see there's a Python package there that got removed. And now we're going to go ahead and we are going to create our new user. So I have created a basic copy and paste here in my Visual Studio Code. I'm going to put this on the blog so that you guys can copy and paste along with me. Again, not because I'm lazy, but it's because I'm lazy, right? I could stumble through these commands, or I could just copy and paste them and make this go a lot easier. So first thing we're going to do, we're going to add a user. We're going to give that user a password. Actually, let's make sure that's a secure password. We're going to confirm it. Give it a name. Not going to worry about those. Fantastic. Then we're going to go ahead, we're going to add my new user to all the groups that it needs to be in. And then we're going to go ahead and we are going to log in as my new user, which is fantastic. And we're going to kill all of the sessions for the Raspberry Pi, which is going to knock me out so you can see, because the SSH connection was established over the Pi user's login, even though I had I had SU'd to cjoyce, I was still connected originally as Pi. So we need to reconnect now, and we're going to reconnect with cjoyce, not with Pi. Okay, so still, hey, SSH enabled on the default Pi account. So we're going to fix that. And we are going to delete the Pi user. And then we're going to go ahead and we are going to make sure, oops, there we go. Excellent. And now we need to go ahead and we need to update the sudoers file to say, hey, cjoyce needs to put in a password every time he wants to use sudo. So we're going to take this line, we're going to replace Pi with cjoyce. Okay, great. And then we're going to make sure that that update took. We're just going to cat that out real quick. And boom, we're good to go. Okay, the next thing that we need to do is we need to update our SSH conf. So let's go ahead and sudo to it, or sudo nano. Here's our SSH conf. And we need to add and remove a few things. So the first thing that we need to do, public key authentication, we need to enable that. We need to go ahead and we need to allow and deny some users. We're going to allow our user that we've created, and we are going to deny some normal usernames, right? So basically, if anyone tries to fingerprint the Pi, so if they get past all the defenses and they're on the network, and they try to fingerprint the Pi and they try to log in, it's just another way that we can defend to say, hey, these users, no matter what, not allowed to connect. We are going to update to password auth no. Okay, and then we're going to come down, challenge and response auth is going to be no, and we want use PAM to no. Excellent. We're going to save that configuration. The next thing that we need to do before we restart SSH is we need to do an SSH keygen. And the SSH keygen is something we need to do on the local Mac. So we're going to run that here. Now, if you're running this on Windows, there's some great tutorials out there for PuttyGen and how to build SSH keys with Putty. But since I'm working off of a Mac, we're going to do it the Linux way. So SSH Keygen. We are going to go ahead and we're going to say we want to do that in/users/cjoys/.ssh/ and we're going to call this TSSNPI01_cjoys. We're going to give it a passphrase. Now, this passphrase should not be the same passphrase, or rather password, as your local user for the Mac. It shouldn't be the Pi user. This should be just a unique passphrase for the certificate. Okay, so now we have that. We are going to do an ls of SSH. Okay, cool. So we can see that I've got another key, and then I've got the new keys that I've just created here. So now we need to update this to be TSSN Pi01_cjoys .pub. Actually, it'll be just that. Okay. And now we need to give it the remote password. Okay, so we've got key, we've got. Okay, so now we're going to go ahead and we are going to SSH to the Raspberry Pi. We're going to use the key that we've created, the user, and of course the address. It's going to ask for the passphrase for the key. And here we are. So again, we're logged in. So the really important thing here is, again, we want that password to be unique to this key file. And this helps prevent compromise of local credentials, remote credentials, etc. Right? Someone else has your password, they don't have your key pass. So a little bit of a cheap 2FA. So now let's go ahead and let's do a SSH restart. And we're going to restart this service. Now that we know, and we want to be really careful to restart this service after we've validated that our key pair works, our identities are working, all of those things. And the reason being is that if we restart the service after we change the config file, but we don't do any of the validation, there's really not a great way to get back in without essentially reinstalling the OS and starting from scratch. So just make sure you test everything before you restart this service. I'm going to log out now. And if I try to just SSH cjoys at 10.1.2.63, you're going to see that permission is denied, right? It's looking for a key. So let's go ahead. Let's give it the key. And now we're logged back in. So now SSH is no longer going to accept passwords for logins. It is going to require key files. This is pretty standard Linux security, but again, is something that you need to do on your Raspberry Pi. So the next thing that we need to do is we need to install UFW. Okay. UFW is going to get installed. So UFW is installed, and before we enable UFW, let's go ahead and set some rules. So the rules that we need to set, we are going to create a rule to limit SSH. Essentially what this is doing is it's allowing connections to SSH, but it's rate limiting them. So this is going to help with potential brute force attacks. So if someone does get inside the network, tries to brute force the SSH. This is going to limit that. And then, of course, I've got a ports list here for all the ports that I know are going to be needed for our unified controller, our Cloudflare, Pi-hole, Kismet, everything that I can think of off the top of my head is here. But of course, as we install these packages, if we need to, we can always modify these rule sets later. So I'm going to go ahead and I'm going to start copying and pasting these guys. And get these guys in. And as I'm looking through the list, I realized I did forget one, which is 2501. That's for Kismet. So we're going to go ahead and we're going to update this. And that is going to give us that. Okay. Okay. It's going to warn us that it might disrupt the connection. We're going to say yes, because we know that that's going to be fine. Fantastic. So now we're seeing all of our rules for V6 and V4. We're allowing them from anywhere, and we can see this. Now, if we wanted to, we could have gotten a little bit more granular. We could have allowed only from internal network. We could have allowed only from specific hosts. And the way that I kind of look at this is we're relying on the hardware firewall to do a lot of that limit for us, and to kind of limit the inter VLAN connections as well as external to internal connection. But again, if you want to get more granular, you certainly can. In this particular case, I'm not going to, but we absolutely could have specified IP ranges. Okay, so the next thing, now that UFW is done, next thing that we need to do is let's get into overclocking. So we are going to edit the boot config, and we're going to come down to, there we go, ARM frequency. And we are going to change this to be 2100. And we are going to change the overvolt to 6, which is the maximum you can overvolt, which is what you need to support a 2100 megahertz clock speed. We're going to save that. We're going to reboot. And then we'll wait for this to come back up. Now, while we're waiting for this to come back up, just some notes on the overclocking. First things first on overclocking, you really do want to make sure that you have some sort of active cooling. The Raspberry Pi does get very hot very quick, even without overclocking. And so having an active cooling case of some kind is going to be very important. But the second thing to think about is the fact that the Pi will throttle the CPU, and you can't control it if it gets too hot. So if it goes above 80 degrees Celsius, it starts to throttle it back down. So there's no point in overclocking if you're just going to continuously hit the heat throttle and be pulled back down. Second thing to know about overclocking is that you do want to make sure that you have a 3.1 volt power supply. I am using an Anchor charger with an Anchor cable. It's a USB-C charger. It provides 3.1 volts to the USB-Cs. So it's essentially the equivalent of using the stock Raspberry Pi USB-C. But again, just be very cognizant of the cable and the charging brick that you're using, making sure that it can actually provide 3.1 volts to the Pi. And then the last thing to be aware of with overclocking is that depending on what base firmware your Pi is running, if you have an older Pi 4B that doesn't have the newer firmware version, you need to go ahead and do the Raspberry update so that you can get that newer firmware and allow for overclocks above 1.75 gigahertz. So initially, when this was launched, 1.75 was kind of the cap. Then 2.147 was the cap, and then allegedly there's now a new firmware available that'll let you go to 2.4. For me, 2.1 is kind of this happy medium. The other thing to know about the overclocking is GPU overclocking is available. You can absolutely overclock your GPU. For what I'm doing, I haven't found any benefit in overclocking the GPU, so I just leave that as is. But we'll go ahead, we'll log back in now that this guy has rebooted. And we're going to go ahead and we are going to update the CPU throttling here to be performance. We're going to go ahead and do CPU star there instead of CPU 0 so that it's for all cores. Just make sure real quick. Awesome. Okay, so we are set to performance, and if I do sudo cat, and then I do this guy, and then I do star. Okay, so all 4 cores now, CPU 0 through 3, are all set in performance mode, and so now we know that all the cores are going to run in that 2 gigahertz mode or the 2.1 gigahertz mode all the time, unless either thermal throttled or voltage throttled. So the default mode, which is energy saving, basically it ramps the clock speed up as you need more CPU, and then it ramps it back down. In my case, I'm really not concerned with power draw on the Pi, and I'm also really not concerned with the additional stress that this is going to put on the Pi board. The Pi 2B, or sorry, the Pi 4B 2 gig is a $35 board. If this burns itself out, it'll be a good excuse for me to upgrade either to one with more RAM or a Pi 5 when those come out. So again, I'm not personally concerned about this, but if you do want to extend the longevity of your Pi, maybe leave this last step out. Just overclock it so the max frequency is 2.1, but we'll let it go from there. So just as a quick recap for today, what we covered in today's video, step 1, we got our installation of Raspbian 5.10 Lite completed. We got it updated. We created a new user. We removed the default Pi user. We installed the UFW and set up our firewall rules so that we have some control over what's coming in and out of the Raspberry Pi. And then we overclocked the CPU so that it can handle running all of our packages with little to no performance hiccups. In our next module, we're going to look at installing both Pi-hole DNS and Cloudflare. And then after that, we're going to start looking at Unify. So thank you very much for coming with me, and stay tuned.